Hi, welcome to today's lesson. What we're going to be looking at today is fractions that lead to quadratics. Okay, I say that like that because I know that this is probably one of the most difficult things in algebra that we're going to be looking at. Fractions that lead to quads. Well, let me put a proviso on it. This is the most difficult thing that you'll be looking at if you don't go into differentiation and integration, okay? So if you're sticking just with, in England, it would just be the GCSE, okay? Alright? This is one of the most complicated algebra things that you can look at. Alright? So, let's take a look at this. So, e.g. We're looking at 5 over 2x plus 1, 2x plus 1, plus 6 over x plus 1 equals 3. Okay, so with this, right, the reason, the thing with this, you need to be careful with this because the first thing that I notice is that I've got binomials, two different binomials. Binomial, two terms. Bicycle, two wheels, binomial, two terms. I've got two different binomials here, and as soon as I find the lowest common denominator of the two different binomials, okay, which is just the two binomials times together, I'm going to get 2x times x, which is going to result in x squared, yeah. So that's going to be where this quadratic is going to come out of here, okay. If I had a binomial, alright, and if I had two monomials, then I might not get a quadratic. Sometimes you do, but sometimes you don't. In this case, I definitely will get a quadratic. Okay, so let's take a look at this. The first thing I want to do is I want to just quickly write this out. I've got 5, I'm going to leave some space, plus 6 equals 3. And at the bottom here, I'm going to write the two binomials. I've got 2x plus 1, that's that one, right? Times by x plus 1, that's that one. Okay, and now I stop and I say to myself, okay, great, Mr. Roosh, what does this need to look like this? And all that this needs is the red part. So, to be fair, I need to get the red part to the top there, x plus 1. Alright, same thing. What does this need to look like this? It just needs the blue part. So I have to give the 2x plus 1 to the top there. Everyone with me? Okay. Now all we have to do is tidy things up. So all that I'm going to do is I'm going to distribute out this 5 into both of those, and then I'm going to distribute out the 6 into both of those, and I'm going to FOIL out at the bottom here. Alrighty. So let's do it. On top, 5 times x is 5x, 5 times 1 is plus 5. Okay? Plus. Okay, 6 times 2 is 12, 12x. 6 times 1 is 6. All over, at the bottom here, you all still with me? Okay? All over, let's do the FOIL on this. 2x times x is 2x squared. 2x times 1 is 2x. 1 times x is x. 1 times 1 is 1. Okay, all of that equals 3. Everyone with me? So all that I've done is I've multiplied everything out. Now I'm going to tidy things up. Let's add together things that can go together. So 5x plus 12x is 17x. Okay, 5 plus 6 is plus 11. All over, at the bottom here, 2x squared, 2x squared, 2x plus x is 3x, plus 3x, plus 1. All of that equals 3. Okay, right. Phew, hectic. But we're not finished yet. Let's go on to the other page so I can carry on and solve this. I need to find out what x is. Okay. So, on the other page, and here's one I made earlier. I love it when TV chefs say that, so I get to say it. Here's one I made earlier. Okay, so now we're at this stage. This is just the last line of my previous page. Yes, I've just rewritten it. So now we're at this stage, and what I'm going to do is now I'm going to do opposite to other side to get x alone. So the first thing I'm going to do is I'm going to say, okay, what's the opposite of divide by the denominator? Well, it's times by the denominator, times the other side. So the 17x plus 11 stays on this side, equals 3 times by this denominator. And the denominator that I've got there is 2x squared plus 3x plus 1. Everyone with me? Okay. So I've just cross-multiplied by the denominator. Okay, so let's tidy everything up. Let's distribute this 3 to there, all right? Okay, and then we're going to bring the 17x plus 11 over. I'm going to do 2 moves at once, all right? Because why do I want it all over? Because it's a quadratic. So for quadratic, I want everything to equal 0. Now whether you've got everything on the right equals 0 or everything on the left equals 0, it doesn't make a difference, okay? So let's just quickly do that. First thing, I've got 0 here because I've taken everything across, equals. Now the distribution, okay? 3 times 2x squared is 6x squared. 3 times 3x is plus 9x. 3 times 1 is plus 3. Everyone with me? Now, I'm going to minus 17x. Opposite of plus 17x is minus 17x. Minus 17x. Opposite of plus 11 is minus 11. Minus 11. Okay? So I've just taken everything there and distributed. I've done 2 moves in one. You could break this down into 2 separate lines. No worries if you do. Okay? Alright, now I'm going to tidy everything up. Over here, 0 equals, let's put the x squared together. Well, there's only 6x squared, 6x squared. Okay. 9x minus 17x is minus 8x. You with me? And 3 minus 11 is minus 8. Okay, fantastic. Right. Now, oh, look, even. Let's take out a 2 just so that I can make my factorizing easier. So we still have 0 on this side. You'll see why I'm color-coding it in a second. 6x squared divided by 2 is 3x squared. Minus 8x divided by 2 is minus 4x. Alright? And minus 8 divided by 2 is minus 4. Okay, fantastic. Nothing more can come out of that. Okay. So, now we've got a quadratic which we can solve. I would suggest always solving by inspection. Okay? Factorizing, not the quadratic formula completing the square. Okay, so factors of 4 and factors of 3, that give me minus 4. So factors of 3 are 3 and 1. Factors of 4 are 4 and 1 and 2 and 2. Okay, now I want to see how do they combine to give me this minus 4. Okay, this is why you have to have seen solving quadratics before you come into this one. So, let's do it. 3 times 4 is 12, 1 times 1 is 1. I either get 13 or 11. Doesn't work. 3 times 1 is 3, 1 times 4 is 4. I either get 7 or 1. So I can't get 4 from those two. You with me? 3 times 2 is 6. 1 times 2 is 2. I either get 8 or 4. Fantastic. I want 4. So that's how I'm going to do it. So I've got here 0 equals brackets. Okay. I've got 3x. I've got 1x. And I want the 3 times the 2, so the 2 can't be in the same brackets, and I want the 1 times the 2, so the 2 can't be in the same brackets. You don't really have to stress about that when you have the same factor repeated, okay? Alright, so let's take a look at what they are. This sign is negative, so it says the signs are different. This goes to the biggest combination. Well, what's bigger, 3 times 2 or 2 times 1? 3 times 2 is bigger. Okay, so that's negative, so that must be positive because the signs are different. And now we're done. We are completely done. From this side, I get 3x plus 2 equals 0. So x equals opposite plus 2 is minus 2. Opposite times by 3 is divided by 3. Negative 2/3. And from this one, I just get x minus 2 equals 0. Opposite minus 2 is plus 2. Fantastic. And we have our two answers. X equals negative 2/3 or x equals positive 2. Whew. Alrighty. Okay. That was a big one. That tested almost absolutely everything that we've done so far in algebra. Okay? Well, the majority of stuff that we've done so far in algebra. Okay? Unless you get onto integration and differentiation, okay, or a little bit of straight line work, this is a very, very powerful algebraic question. And I would most likely like to put it into a non-calculator test. Alright? So where you can't use the quadratic formula to solve it, you have to use inspection or completing the square. Put it into a non-calculator test as probably one of the last questions. Okay, to separate out the man from the boys. You know what I'm saying? Okay, it is challenging, but it's not impossible. It's not very difficult. You can go and learn how to do these things. Okay, go watch the video again. Go slow down, replay certain steps. Then go find some yourself.
go look specifically for ones with two different binomials in the denominator, okay? Like x plus 3 and x plus 4, or 2x plus 9 and x minus 7. Whatever the binomials are, it doesn't make a difference. Just go find one with two different binomials in the denominator and work it out. Okay, even make one up yourself and then work it out using a calculator too, because it'll always work out. You'll always be able to find something, alright? It just might not be nice whole numbers like this. Alright, okay, go practice that, and remember, I'm here for you.